Good morning, class. How are you?
Good morning, Miss Linda. We fine, thanks. And how are you?
No, I'm okay today. Okay, let's just wait for until 1:15, then we begin. Okay, there's still 25 people, but at 1:15 we are definitely start with whichever number we are going to have.
Good morning.
Morning, how are you?
Thanks and yourself, Mandino.
Yes, I'm okay. I'm fine. Okay, we are waiting for 1:15, then we start. Okay, we can begin. We can begin, and I hope you can see my slides. We can begin, and I hope you can see my slides. Okay, we are on managing multiple environment configurations.
Amanda,
Okay.
on my side, there's nothing for.
Okay,
Yes, ma'am. We cannot see your slides.
okay, let me try to share again. Thank you. When you see it, you tell me.
We can see your slides now, ma'am. At least on my side.
Okay, thank you. Okay, let's begin. Managing multiple environment configuration. When developing an application, you're most likely to have a number of environments that your code will need to run in. For example, you may have a development environment, a staging or a testing environment, and a live production environment. So there is a what? A development environment, staging or a testing environment, or a live production environment. If each member of your team is developing an application on their own machine, then they may each have their own specific environment requirements. Environment properties. Your application will have a standard set of environment properties that differ within each environment. This may include data source details, file path, and domain names. You may also have a set of configuration properties that should be the same across all of your environments, such as a company name or application constants. Let's assume that for each of your environment, you need the following variable properties defined. So your asset path, document path, data source name, data source user, data source path, and assume the common properties for your environment are asset URL, document URL, company name. There are many ways of storing this information, but a common technique is to use the XML file. So I encourage you to go to your YouTube. Then you are going to also watch the development, the development environment, then or a testing environment and live production environment, multiple environment configurations. Okay, I'm going to give you time to do this activity. Okay, I'll give you about 30 minutes to do this in partners or groups. You can do it individually, you can do it in partners over the WhatsApp call, whatever you have to do. Where I'm giving you 30 minutes, and also go to YouTube and watch the videos. In partners or groups, describe the following categories of computer system applications: embedded systems, Windows applications, also called desktop applications, web services, console applications. Okay, let's do this until 9 o'clock. So let's do this until 9 o'clock. Okay, I hope my instructions is clear. Let's do the work until 9 o'clock. You can do it individually, you can do it in partners. Okay, is the instruction clear? Is the instruction I'm giving you clear?
Yes, ma'am.
Yes, ma'am. Clear.
Okay, thank you. Until 9 o'clock. Okay, it's time that we revise. It's time that we revise our work. I hope you can see it. In partners of a group, describe the following categories of computer system applications. Embedded systems. Okay, who wants to go for these embedded systems? Okay, thank you. You can go ahead. Yes, Ivan.
Oh, sorry, ma'am,
Follow
I
after.
didn't hear you calling my name. So basically, the categories of embedded systems. So basically, just to define embedded systems, they are the specialized computing systems that perform dedicated functions within larger systems. So they are part of hardware devices that are embedded into the system they control. They operate with limiting processing power, memory, and storage, and also they are designed for high reliability and stability to function continuously without failure. Examples can include automotive control systems, household appliances, or even medical devices and industrial machinery.
Okay. Thank you so much. Thank you so much, Ivana. So we have Samkele, then Brandon, then Anele. Yes, thank you, Ivana. Samkele, then Samkele, go next.
Okay, ma'am, then. All right. Embedded system is a microprocessor-based computer hardware system with software that is designated to perform a dedicated function, either as an independent system or as a part of a larger system. Its key features include designed for a single or limited set of tasks. It is part of a bigger device, often invisible to the user. It responds to events in a timely manner, often with strict deadline, and it has limited resources such as a small processor, limited memory, and specialized peripherals. Thank you.
Okay, thank you so much. Thank you so much, Samkele. Thank you for your contribution. We have Brandon, then Anele will be the last. Brandon, go ahead.
Okay, so web applications are accessed via a web browser and rely on a network such as the internet or an intranet for functionality. These applications like Google Docs, Facebook, and Gmail are designed to run on web technologies including HTML, CSS, and JavaScript. Web applications require an active internet connection and are typically used for tasks that involve real-time collaboration or data sharing across devices. Thank you.
Thank you so much, Brandon, for your contribution. Thank you so much. It is noted. Then lastly, Banele. Banele, you can go ahead.
Embedded systems are a combination of computer hardware and software designed for a specific function. Embedded systems might also function within a larger systems, and they can be programmable.
Okay, thank you so much. Thank you so much, Banele, for your contribution. It is noted. Thank you for doing your work. Okay, I think we have heard enough. Is there anyone who wants to add anything? Okay. If there's no one, I think that was enough. Let's go to Windows applications, also called desktop applications. Okay, what type of computer system is it? Yes, anyone who wants to go for this Windows applications or desktop what applications? Windows application, also called desktop application. Yes, we've got Brandon, then SA2, anyone else? Then Samkele, then Tapelo. Okay, let's go for this for now. Brandon, SA2, Samkele, Tapelo. Okay.
Okay, apologies for doing web applications before this. I thought we were just like doing one each or something. So we're
Okay,
doing
no-
Windows applications, right, ma'am?
Yes, yes.
Okay. Windows applications, also known as desktop applications, are software programs that run locally on a computer's operating system, such as Microsoft Windows. These applications include popular tools like Microsoft Word, Adobe, Photoshop, and File Explorer. Windows applications are typically equipped with graphical user interfaces, abbreviated as GUIs, and are installed directly on the device where they can be used without the need for an internet connection. Thank you.
Okay, thank you. It is noted. It is noted, Brandon. Thank you for the point that they can be used without the network connection, without internet. I mean internet connection. Okay, that is a valid point to take into account. Thank you, Brandon. We go to SA2. After SA2, Samkele, then Tapelo. Okay, SA2, go ahead.
Okay, ma'am. I have a very brief description. So the Windows applications, also known as desktop applications, are software programs designed to run on personal computers with a Windows operating system. These applications typically have a graphical user interface and provide a range of functionalities of users. Examples include Microsoft Office Suite, for example, Word, Excel, or PowerPoint, and Adobe Photoshop. And
Okay,
the
thank you so
characteristics have the first ones that they installed directly on the user's device, can operate offline and utilize the local system's resources effectively. The last one being they are generally designed for specific tasks and may have extensive features. Thank you.
Thank you so much, SA2, for the point. Thank you so much. It is noted, and thank you for doing your work. We have Samkele. Samkele. Yes, go ahead, Samkele.
All right. Windows application, a software program designed to run on the Windows operating system, providing the user with a conveniently powerful way to interact with their computer to perform various tasks. They come in different forms and are developed using various tools and programming languages, making them essential for personal and professional productivity. Thank you.
Thank you so much, Samkele. It is noted. Thank you for the valid points. I saw Tapelo that he left. Tapelo, are you back? Maybe you are having an internet issue, a connection issue. Okay, anyone who wants to add to what Brandon, Eset, and Samkele just said? Is there anyone who feel like they need to have they have their valid points they need to add on Windows applications? Okay, is there anyone who feels like they need to add something? Okay, let's learn to participate, class. Some of you, I don't even know you, but you are left with less than a month. Like we are left with a month to finish this. So let's learn to participate. Okay, it's noted back, Tapelo. Let's just move on to the next one. The next one says web applications. Web applications. Who wants to go for this? Let's have different people participate. Thank you, Google Fortunate. Who wants to go again? Google Fortunate, Tyrene, thank you. Yes, anyone else? Paul, thank you. Okay, so it's Google Fortunate, Tyrene, Paul. Anyone else? Google Fortunate, Tyrene, Paul. Anyone who wants to come? Edrefilo, thank you. So it's Google Fortunate, Tyrene, Paul, and Refilo. Okay, thank you. Google Fortunate, go ahead.
Okay, ma'am. Web applications are software applications that run on web servers and are accessed through web browsers over the internet or an intranet. Unlike desktop applications, they don't need to be installed on a local machine. Web apps are platform independent and work across various devices. As long as there's a browser available, examples like Gmail, uh, Facebook, and online banking systems. That's the description I got for web application. Thank you.
Thank you so much, Gugu. Fortunate Mashaba. Thank you so much for your answer and for your contribution. Okay, Tapelo will be back. Tapelo, you be the last one on this. Let's go to Tyrene. Tyrene, then Paul, then Refilo, then you come back to Tapelo on your contribution. Tyrene, go ahead.
Good morning. I hope you guys can hear me. I just want to say the web applications. The definition for it is that it's software that runs on web servers and it's accessed through browsers. Examples include Facebook, online banking, e-commerce websites, social media platforms, and then online learning platforms as well. Thank you.
Okay, thank you so much, Tyrene, for your contribution. It is noted. We have Paul. Paul, go ahead. Then Refilo, then Tapelo. Paul, go ahead. Paul?
Okay, my answer is kind of similar, but web applications are software programs that run in a web browser and can be accessed via the internet. They are platforms independent, meaning that they can run on any operating system with a compatible browser. For example, Google Workspace, which is the Google Docs, Sheets, and Slides. And then we have social media platforms like Facebook and Twitter, and e-commerce websites like Amazon and eBay. Thank you.
Okay, thank you so much. Thank you so much, Paul, for your contribution. It is noted. Then we have Refilo. Refilo, go ahead.
Web applications are software programs that are accessed through web browsers running on most servers and offer a wide range of functionality and services. They are characterized by their web-based features, requiring online connectivity to function, and provide dynamic content that can be updated in real time. Web applications are scalable, platform independent, and can be accessed from anywhere with an internet connection. Examples include social media platforms like Facebook and Twitter, online banking, and e-commerce sites like Amazon, email services like Gmail. Thank you.
Okay, thank you so much. Thank you so much. Then you go to Tapelo. Yes, Tapelo, you wanted to answer the previous question where you had gone.
Should I answer the previous question or the current one?
Just answer the current one.
Okay, so web applications are software programs that run on web servers and are accessed through web browsers over the internet. Web applications are characterized by their client-server architecture, where the client or the user's browser interacts with the server, where the application is being hosted to exchange data. They typically use standard web technologies such as HTML, CSS, and JavaScript for front-end, while the backend can be built using various programming languages like Python, Ruby, PHP, or Node.js. Web applications can be static, where content does not change unless manually updated, or dynamic, where content is generated in real time based on the user's interaction or database queries. Thank you.
Thank you so much, Tapelo, for your contribution. It is noted. Okay, thank you so much to all the participants. It is noted. I truly appreciate that. Then you go to web services. Here it's web services. Anyone wants to give us an answer? Web services. Okay, let's see whose hand is up. Let's see the people whose hand is up. So far, there's no one with a hand up. Okay, I don't mention names, they just participate. Okay, thank you, Esetu, thank you, Brandon. Who else? Let's have more people. Esetu, Brandon, Paul, and Samkele, thank you. Okay, let's go in that order. Esetu, Brandon, Paul, and Samkele. Esetu, go ahead.
Okay, ma'am. Web services are standardized methods of communication between different software applications over the internet. They enable interoperability between applications running on various platforms and are often used in the context of service-oriented architecture, the SOA. Examples include RESTful APIs, which is representational state transfers, and the SOAP, which is Simple Object Access Protocol services. The characteristics include the following. They use standardized protocols such as HTTP, XML, and JSON for communication. They allow different applications to share data and functionalities regardless of the underlying platforms. And the last one I have, it facilitates integration between disparate systems. Thank you.
Okay, thank you so much, Esetu, for the contribution. It is noted. We go to Brandon.
Yeah, web services are programs that enable communication between different systems or devices over a network, utilizing standard protocols such as HTTP, XML, SOAP, or REST. They allow for seamless data exchange across different platforms, enabling functions like accessing weather APIs, payment gateways, and cloud-based storage services. Web services are crucial for facilitating integration between applications in a platform-independent way. Thank you.
Thank you so much, Brandon, for your answer. We then go to Paul.
Okay, web services are standardized methods for integrating web-based applications using open standards over an internet protocol backbone. They enable different applications to communicate and share data. For example, PayPal and Stripe payment processing services, and then data retrieval services like Twitter API, Google Maps API, and then cloud storage services like Amazon S3, Dropbox API. Yes, that's all I have on my side.
Okay, thank you so much, Paul, for your contribution. We go to Samkele.
All right. Web services are fundamental building blocks of modern application development, enable communication and data exchange between different software systems over internet. A web service is a software application that exposes its functionality over a network, typically using a standard protocol like HTTP or XML. This means that it allows other application or client to interact with capabilities remotely, regardless of their platform or programming languages. Platform independence. Client server can be written in different languages and run on different operating systems as long as they adhere to the established web service standards. Yes, that's all, Linda.
Okay, thank you so much, Samkele, for the contribution. It is noted. Okay, thank you, Ese, to Brandon Point, Samkele, for doing your work. It is appreciated. Then lastly, console applications. You can pronounce it differently. Yes, that's fine. Console applications. Yes, let's see, we've got their hands up. Okay, we've got Brandon. Yes, who else? let's learn to participate. Google Fortinet, you've got Brandon, Google Fortinet, who else? Who else? I don't want to choose on people. Brandon, Google Fortinet. Let's have 2 more people. Let's have 2 more people. Sandile Smelane. Okay, thank you. Let's have another person. Okay, let's have another person. I have Brandon, Google Fortinet, Sandile. Who else wants to go in? Who else wants to come? Who else? Besides Brandon, Google Fortinet, Sandile, another person. Okay, let's go to Brandon.
Okay, ma'am. Console applications are text-based programs that operate within a command line interface for going graphical user interfaces. These lightweight applications are often used for administrative tasks, scripting, and development processes. Examples of console applications include terminal programs, compilers, and automation tools where interactions take place through text commands instead of visual prompts. Thank you.
Okay, thank you so much, Brandon. We go to Google Fortinet.
Okay. My answer is the same as Brendan's, but I'm going to say it anyway. Console applications are text-based applications that run in a command line interface environment. They do not have a graphical interface and are often used for simpler tasks or automation of system-level operations. They are typically faster and require fewer resources than Windows or web applications. Developers use console applications for utilities like compilers, backup scripts, or diagnostic tools. Examples include command line tools like JIT or the Windows command prompt. That's my piece, ma'am. Thank you.
Okay, thank you so much. Thank you so much, Google Fortinet, for your contribution. We then go to Sandile Alex Milan.
Okay, ma'am. Console applications are text-based programs that run in a command line interface, CLI. They are interact with users through text input and output, and often used for system administration or automation tasks. Thank you.
Okay, thank you so much, Sandile Smelane, for your contribution. Have Banele. Banele, you're also raising up your hand. You can go ahead.
Console application is a computer program designed to be used via text-only user interface, such as text terminal, the command line interface of some operating system. It facilitates the reading and writing of characters.
Okay, thank you so much. Thank you so much, Banele. Okay, let's move ahead. Thank you, Banele. It is well noted. Okay, let's continue with our slides. Okay, thank you for everyone. Yes.
Sorry, ma'am. Can I just be excused for a few minutes, please?
Okay, it's noted, Brandon. It's all right. Okay. Okay, we are moving ahead now. Information systems and office application software in organization. Standard office suite tools, word processors, spreadsheet, presentation packages, end user database packages. Basic user function of a desktop operating system. Office systems like electronic mail, conferencing, corporate work environments, web browsers. and other online services and methods. World Wide Web, www, then FTP, web search engine, and web boot. There are many web search engines like Firefox and all. Specialized systems, that is statistical analysis, expert system, DSS, GIS, BI, electronic data interchange, enterprise wide systems like ERP, CRM, customer relationship management, SCM, supply chain management. Then we have the description explains the performance characteristics of the categories. Higher performance in high disk drives comes from devices which have faster performance characteristics. These characteristics include those with rotating media, hereby called rotating drives, that is hard disk drive, HDD, floppy disk drive, optical disks, DVD, RW or CD, RW, and it also covers services without moving parts like solid state drivers. For solid state drivers, most of the attributes related to the movement of mechanical components are not applicable, but the device is actually affected by some other electrically based element that still causes a measurable delay when isolating and measuring that attribute. Okay, I pose a question to you. What is a solid state driver? Describe a solid state driver. I'll give you 5 minutes only. Describe a solid state driver, SSD. 5 minutes from now, then you'll be able to answer. For share, you're raising up your hand. I can see share, you're raising up your hand. Is everything okay? Okay, let's see this. Let's see define a solid state driver here. Here you see here they're talking about solid state drives, SSD. So describe the SSD. What is it? What is its purpose? I'm only giving you 5 minutes. 9:28. Okay, we'll stop at 9:35. 9:35. Describe a solid state drive. Okay. Okay, then let's have answers. Let's have answers. What is a solid state drive? What are solid state drives? Their purpose. We have panel. For share, I don't know if you guys have your hands. We have SA2. Okay, we have Sibusi. So let's go with those ones. Panel, SA2, Sibusiso.
Okay. SSD is a new generation of storage device used in computers. It stores data using flash-based memory, which is much faster than the traditional hard disk they've come to replace. It is a type of storage device that uses integrated circuit assemblies to store data persistently.
Okay, thank you so much, Banele. Then you've got what? SA2, then Sibusiso.
Okay, a solid state drive, SSD, is a type of data storage device that uses flash memory to store data, providing faster access and improved performance compared to traditional hard drive HDDs. And these are some of the key features of an SSD. SSDs offer significantly faster read and write speeds compared to HDDs. This results in quicker boot times, faster file transfers, and improved overall system responsiveness. In terms of the durability and reliability, since SSDs have no moving parts, they are more resistant to physical shock and vibration compared to HDDs. This makes them more reliable and less prone to mechanical failure. SSDs consume less power than HDDs, which can lead to longer battery life in laptops and reduced energy costs in data centers. They come in various form factors rather, including 2.5-inch drives, M.2 drives, and PCIe NVMe cards. This allows for flexibility in installation and use, whether in laptops, desktops, or servers. They are available in a range of storage capacities, typically from 100 gigabytes to several terabytes. However, they tend to be more expensive per gigabyte compared to HDDs. They operate silently and generate less heat compared to HDDs, which can contribute to a quieter and cooler computing environment. That's all, ma'am. Thank you.
Thank you so much. Thank you so much, SA2, for your answer. Thank you, Banele. We then go to Sibusiso. Sibusiso, may we have your answer?
Okay. Non-volatile power. They are SSDs. The SATA SSD, PSELE SSD. There's an ED, an M.2 SSD, and then a U.2 SSD. That's it, ma'am. Thank you.
Okay, thank you. Though you have sort of breaking up at the first, but thank you so much, Sibusiso, for your
Okay, thank
answer.
you.
Okay, for SSDs, most of the attributes related to the movement of mechanical components are not applicable, but the device is actually affected by some other electricity-based element that still cause a measurable delay when isolating and measuring that attribute. These performance characteristics can be grouped into two categories: access time and data transfer time or rate. Then you go to access time. A hard disk had on an access arm resting on a hard disk platter. The access time or response time of a rotating drive is a measure of the time it takes before the drive can actually transfer data. So this is what we mean by access time or response time of a rotating drive is a measure of the time it takes before the drive can actually transfer data. The factors that control this time on a rotating drive are mostly related to the mechanical nature of the rotating disk and moving heads. It is composed of a few independently measurable elements that are added together to get single value when evaluating the performance of a storage device. Okay. But the access time can vary significantly, so it is typically provided by manufacturers or measured in benchmarks as an average. For SSDs, this time is not dependent on moving parts, but rather electrical connections to solid-state memory, so the access time is very quick and consistent. Most testing and benchmark applications do not draw a distinction between rotating drives and solid-state drives, so they both go through the same measurement process. The key components that are typically added together to obtain the access time are sync time, processing time, and setup time. Go to activity 4, which you are going to revise after break. Explain your understanding to the term computer architecture. Implementation of the computer components in terms of hardware, firmware, then software. Also, and disabilities. So we can start with these activities for 7 minutes for revise that activity. So it's time for you to do this activity and urge people to participate. To them, like regular participants, you can also participate. This will be our break. Okay.
Ma'am Linda. When are we revising this, guys?
We are
I think after break.
we are revising after break. And can you hear me, class? Can you
Yes,
hear
ma'am,
me
we
all
can
the
hear
time?
you. We
Yes,
can
we
hear
are
you, Ms.
revising.
Linda.
Thank you, Tyrone. We are revising after break. 10 o'clock, we are going to take your break. Then you come back at 10:30, then we revise. Is it clear? Okay. So when it's 10 o'clock, you are taking your break. I'll see you at 10:30, then we revise. 10 o'clock, you take your break, then we revise this at 10:30. Okay, we are back on. We are back on. Let's revise. We start with this question. Explain your understanding to the term computer architecture. Okay, who wants to answer this question? Okay, we've got Brandon. We have got Noma Sabata. Thank you. We else Tapelo. Okay, let's have Brandon, Noma Sabata, then Tapelo.
Okay, so computer architecture, refers to the overall structure and design principles that govern how different components within a computer system work together. It defines how the central processing unit, memory, storage, input and output devices, and data buses interact to process the data. This includes decisions regarding how instructions are executed, how data is transferred between components, and how resources like memory are managed. In essence, computer architecture provides a blueprint that guides the organization of computers' hardware, influencing both the performance and its capabilities. Thank you.
Okay, thank you so much, Brandon. Okay, we go to Noma Sabata. Yes, Noma Sabata. Okay, if Noma Sabata is having network problems, let's go to Tapelo.
Computer architecture refers to the design and organization of a computer's fundamental components and their interactions. It encompasses both the hardware and the system's underlying principles that enable the computer to function. At its core, computer architecture defines the structure of a computer's processor, memory, and input or output mechanisms, ensuring that data flows efficiently between these components. The field focuses on optimizing the performance, efficiency, and scalability of computers, allowing them to handle complex computations and tasks. Thank you.
Okay, thank you so much, Tapelo. Yes. Is there anyone else who wants to add to what Brandon and Tapelo said? Is there anyone else who feel like adding? Okay, if we have no one, then we go to, thank you, Tapelo and Brandon. Describe a computer and its elements. Okay, describe a computer and its elements. Who wants to come? Tapelo is still raising up your hand.
A computer is an electronic device designed to process data and perform tasks based on a set of instructions or programs. It is capable of receiving input, processing that input, and delivering output. At its core, a computer performs these functions through its main components, which include hardware and software. The hardware consists of physical elements like the processor, memory, and input or output devices, while software includes programs and operating systems that control the hardware. The central processing unit, or the CPU, often referred to as the brain of the computer, is responsible for executing instructions from software programs. It performs calculation, makes decisions, and directs other components to execute tasks. Modern CPUs often contain multiple cores, enabling the computer to perform several tasks simultaneously. Closely related to the CPU is the memory, particularly random access memory, which temporarily stores data, that the CPU uses while performing tasks. And then we have storage devices such as hard drives, HDDs or solid state drives are another critical element. They permanently store data and files even when the computer is turned off. These storage units are used to save operating systems, application, and user files, ensuring that data can be retrieved and processed by the CPU when needed. SSDs in particular are faster and more reliable compared to traditional HDDs, contributing to quicker data access and overall system speed.
Okay, thank you so much. Yes, thank you so much, Tapelo. Yes, Esetu.
No, Masabata has technical issues, ma'am. She cannot open her mic and she cannot write on chats.
Okay, no problem, no problem. Thank you, Eset, noted. Okay, who wants to add what to Tapeles just said? Describe a computer and its elements. Is there anyone who wants to add? Can somebody add before we go forward? Yes, I'm waiting for someone to add before we go forward. So is it only Tapelo who did that question? Okay, we'll not move forward then if you don't want to add. Until we add, then we move forward. Because it's not only Tapelo who did that question. Okay, Chimeka Jacobs, thank you. Go ahead.
So I just have what a computer consists out of. Central processing unit, which executes instructions, the memory RAM, which temporarily stores data and instructions, storage devices such as HDD and SSD, which store data and programs permanently. We have input devices, which is keyboard, mouse, receive user input, output devices, which is monitor or printer, which display or print output. We have the bus, which is communication pathway between components, and power supply provides power to components. Okay.
Thank you so much. Okay, thank you so much, Chimeka Jacobs. Okay, is there someone who wants to add to what Tapelo and Chimeka just said? Is there anyone who wants to add?
I'm Linda.
Yes, for sure.
Yes, ma'am, I don't know what's wrong with my connection. I've been trying to unmute. So
Okay, we can hear you.
I hear.
Yes.
I just want to go to my answer. So
Yes,
from
you
my
can go
understanding,
ahead.
ma'am, it's for computer architecture, right, ma'am?
Yes. No, we are now on computer and its elements.
Okay, so for computer elements, ma'am. So what I said, a computer consists of, ma'am, is we have a CPU, a memory, a RAM, and a ROM, ma'am. So the CPU is a central processing unit. It's basically like the brain of the computer. It executes instructions and processes data. And for the memory, it's temporary storage that holds data and instructions needed by the CPU, which includes RAM memory, like your random access memory, which is volatile temporary data storage while the computer is on. And with ROM, it's read-only memory, which is non-volatile memory. It used to store the firmware memory. And then with input devices of the computer, it's devices that allow the users to connect to the computer, like your mouse, your keyboard, and headset, you name it, ma'am. And then with output devices, you have like your monitor that you use the external screen, or you have a printer. And with storage, we have like long-term storage, long-term data storage, such as your HDDs, your hard disk drives, and your SSDs, which is your solid-state drives. And then we have the motherboard, which is the main circuit that connects all the components. And then lastly, I have the power supply, which provides electricity to the system. That's all I have from my side, Ms. Linda.
Yes, okay. Thank you for your answer. It is appreciated. Thank you so much. Okay, let's move forward. Describe the implementations of the computer components in terms of hardware. Let's start with hardware. Hardware. Who wants to go? Hardware. Please, let's have participants. I gave you time to do your work, and I don't like this, that when I give you time to do your work, then I don't see participants. I'm not in the enjoyment of calling people names, like saying this one, Ongaletu, saying yes, like mentioning people's names. I don't like that. Okay, team maker. After team maker, we've got Brandon. We are starting with hardware. Okay, thank you.
Okay,
Then,
so
okay,
so
team maker, Brandon, Google Fortunate, team maker. Sorry, go ahead. You can go ahead.
okay, hardware implementation, we have physical components such as CPU, RAM, HDD, manufactured using various materials, which is silicon, copper, etc. And it is designed to perform specific functions such as processing as well as storage and etc. Advantages of hardware is fast processing and execution, reliable storage and retrieval, customizable and upgradable, as well as physical security, such as an example, encryption keys. Disadvantages, it's costly to upgrade, as well as to replace. There's physical limitations such as the size, power consumption, vulnerable to damage and wear, and yeah, outdated technology, basically. Obsolescence, sorry. Thank you.
Okay, thank you so much. Let's have Brandon.
Ms. Linda, should I still do hardware because my answer is quite similar to Tamika's?
Yes, you can still do hardware.
Okay. So hardware encompasses the physical components of a computer system, including the CPU, memory, storage drives, and peripherals such as your input-output devices. It provides the foundation for performing computational tasks. Some of the advantages are that it offers direct control over computing performance and power. It is more durable and requires less frequent updates compared to software, and can be upgraded to enhance overall performance. And then some of the disadvantages are it is expensive and difficult to replace or upgrade, and also it is susceptible to physical damage and wear over time. Thank you.
Okay, thank you so much, Brandon, for your answer. We go to Google Fortunate, then Ivana. Fortunate, then Ivana.
Okay, so the implementation of computer components can be categorized into three distinct layers, which is hardware, firmware, and software. So the roles and advantages, also the disadvantages of hardware are the hardware refers to the physical components of a computer system that are tangible, such as the CPU, memory, motherboard, input or output devices, and storage devices. So these elements are responsible for executing instructions and managing data flows. The implementation of CPU executes instructions and processes data. Memory temporarily stores data for quick access by the CPU. Storage devices store data and software permanently. Peripherals, keyboard, mouse, monitor, they allow interaction with the system. The motherboard serves as the platform connecting all components. Cooling systems, they prevent the hardware from overheating. So the advantages are high performance, Hardware can be optimized for specific tasks such as GPUs for graphical processing, longevity, longevity. With proper care, hardware lasts for many years. Customization. Users can upgrade and configure hardware according to their needs. The disadvantages are they are very costly. High performance hardware can be expensive, especially for specific applications, e.g., gaming or server systems. Subject to wear and tear, physical components can degrade over time due to usage and environmental factors such as overheating. Inflexibility, hardware is not easily modified once produced, and upgrading can be complex. Sorry. Thank you, ma'am.
Okay, thank you so much, Gugu. Fortunate. Lastly, let's have Ivana.
Ms. Linda, I do believe that Tamika, Brandon, and Google Fortunate have exhausted the part of hardware. I was wondering if I could please move on to firmware. Is that okay with ma'am?
Yes, you can move on to firmware.
Okay, thank you so much, ma'am. So basically, implementing computer components in terms of firmware is basically just trying to understand how your firmware, or also known as our low-level software, interacts with the hardware to enable functionality and manage hardware resources in the computer. So firstly, I've got the CPU, which is our central processing unit. So when it comes to when the computer starts up or boots, the firmware initializes a CPU and it ensures that it can communicate with other components. For our motherboard, when the computer power ups, the firmware can run posts. Post also, it's a adjective for power on self-test to check the system hardware. It also allows for users to configure hardware settings through a dedicated setup interface. So for our RAM, which is our memory or random access memory, rather, when our computer starts up, the firmware allows the computer to recognize installed RAM models and configures them according to their specifications like speed, capacity, so on. For our storage, the motherboard's firmware interfaces with the storage device's firmware to read and write data during boot processes and when loading applications. Thank you.
Okay, thank you. I believe Ivana is exhausted or on firmware. I think she's about that. Let's move to software. Software. Okay, who wants to do software? Who wants to do software? Okay, let's have participants. Okay, let's have participants, please. I gave you time to do the work. Let's have participants.
Ma'am, can I go ahead?
Yes, Brandon, you can go ahead.
Okay, my answer isn't that long. Software includes programs and operating systems that allow users to perform tasks on the computer. This includes both application software like word processors and system software like operating systems. Some of the advantages are that it is highly flexible, customizable, and suited for a wide range of tasks. It is also easy to update or upgrade to add new features or improve security and performance. It is also scalable, meaning it can run on various hardware platforms. Some of the disadvantages are that it is prone to bugs or glitches, which can affect performance. It also requires regular updates to ensure proper security and functionality. And then lastly, performance depends on the capabilities of the underlying hardware. Thank you.
Thank you so much for the answer. We have Tapelo. Ahead. Yes, Tapelo.
Software refers to the programs and applications that that runs on a computer system, from operating systems like Windows, Linux, Mac OS, and web browsers. Software interacts from both firmware and hardware to perform tasks such as processing data, managing files, and communicating with external devices. Uh, the advantages of softwares are they are highly flexible and customizable, allowing users to change or upgrade application easily. Frequently updated, providing new features, security patches, and performance improvements. They can enhance the capabilities of hardware without requiring any physical changes. And then their disadvantages are that they are susceptible to bugs, security vulnerabilities, and malware attacks. And they are dependent on hardware performance. Resource-heavy software may slow down the system if the hardware is inadequate. Software obsolescence can lead to compatibility issues with newer systems or hardware.
Okay, thank you so much, Tapelo. Then thank you for your answer. We have Esetu. Esetu.
Okay, ma'am, my response is relatively short. So for software, the definition I have is it is a collection of instructions and data that tells the hardware how to perform specific tasks. Software can be categorized into system software like operating systems and application software like word processors. Then I have advantages in it. On advantages, I have it is highly flexible and can be easily updated or modified to meet user needs. It is has a vast variety of applications available for different tasks and industries. The disadvantages is that it can be prone to bugs and vulnerabilities requiring regular updates and patches. Then the last one I have is it has a dependency on hardware performance. Inefficient software can lead to poor system performance. Thank you.
Okay, thank you so much, Esetu, for the answer. Thank you, Tapelo. Let's move forward. Okay. Okay, we have got another activity here. Okay. Explain the concept of firmware. What are the advantages of what firmware? So here, Ivana talked about firmware, just said the advantages. What is the idea of software simulation? Discuss the advantages and disadvantages. Discuss the concept of virtual machines. What is binding? What types of binding? Okay, at language definition and language implementation. Okay, how many minutes do you want to do this? How many minutes do you want to do this?
15, ma'am.
Okay, let's just make it 20 minutes. So at 25 past, okay, just do it up to 25 past, up to 20 past 11. Okay, let's do it up to 20 past 11 and make sure you do your work. Okay, I'm meeting my mic. Let's do it up to 20 past 11. Okay, may you please be encouraged that everyone has to do their work because I can choose on anyone. If we are going to have regular participants, Brenda, Samkel, and all those that who participate regular, I'm going to choose others who are quiet. Okay, let's do this work until 20 past 11.
Ms. Linda, must we also do questions 6 and 7 on the next slide?
Okay, there's question 6 and 7. Let's see. Oh, yes, you must do question 6 and 7 on the next slide. So you definitely need about let's just say, do it up to 25 past 25 minutes. Okay, yes, Paul, do question 6 and 7 as well. Yes, on that, what next slide? Okay. So what types of guide? Yes.
Can I, Paul, if you have the PowerPoint thing, can you please send it to me via WhatsApp?
What types of binding occur at program translation and program execution? What is the advantages of binding? Bindings performed at translation time and okay, yeah, I'll change it and at execution time and at execution time. Okay, start with this one. When you want me okay, start with activity 5. When you want me to move to the next, you tell me. When you want me to move to the next, so okay. We are likely to end with this to continue. Tomorrow we'll continue. Then I urge tomorrow we'll do our work on other questions. Then in the meantime, you're likely to do this work. So I urge Paul, Brandon, and Tyrene to just sort out how they'll facilitate the assessments, because we are nearly getting there. We are nearly getting there next week. Yeah.
Oh, are we gonna do it on Monday, ma'am?
So I'll give you time to do the assessments on your. Let's just say on Tuesday, because I also have to give people time to do their own work so that they'll be able to participate with you.
Okay, ma'am.
Okay. Okay, so let's do this until 25 past. This will be after we revise, we can call it a break for today. We can call it a day. Okay, I'm meeting. Let's do it until 25 past. Okay, we are back on. We are back on. Okay, explain the concept of firmware. What are the advantages of firmware? Okay, who wants to do that? Anyone wants to participate on that one? Okay, Samkele, can you have more than one person? Samkele and who? Can you have other participants? You have 58 of you in the class. Can you have other participants, please? Samkele, essay to then Brandon. Okay, let's have those. Samkele, essay to then Brandon. Okay, go ahead in that order.
Ma'am Linda, I'm struggling to raise my hand, so I don't know why.
Okay. Firmware is a type of software embedded directly onto the hardware components of a device, like motherboard, network card, or even a washing machine. It is written onto a chip called ROM, which stands for read-only memory, which means it is stored permanently on the device and does not need to be loaded from a hard drive. Firmware acts as a bridge between a hardware and an operating system. It tells the hardware how to function at a very basic level, like how to boot up, manage input-output devices, and communicate with other components. Advantages of firmware: hardware-specific functionality. Firmware is tailored on a specific hardware that controls ensuring optimal performance and compatibility. Firmware acts directly with the hardware, eliminating the need of operating system to intervene for basic function. This leads to faster and more efficient operation. It has flexibility and upgradability. While initially embedded in ROM, firmware can be updated through processes called flashing, allowing for bug fixes, feature enhancements, and security improvements. That's all.
Okay, thank you for the contribution. That was profound. Can you have essay to then Brandon?
Okay, the first one, ma'am, I'll move on to the advantages since Ivana exhausted the concept. The first advantage that I have is reliability. Firmware is specifically designed to control hardware components, leading to enhanced stability and reliability of the device. It often operates in a more predictable manner than general purpose software. The second one I have, it's performance optimization. Since firmware is closely integrated with hardware, it can execute tasks more efficiently, resulting in faster operation and reduced response times compared to software that runs on a general purpose operating system. And next I have low level control. Firmware provides low level control over hardware functions, allowing for precise management of device operations. This control is crucial for devices that require real-time processing, such as embedded systems in automotive applications or medical devices. And next I have energy efficiency. Firmware can be optimized to manage power consumption effectively, which is especially important in battery operated devices. It can put components into low power states when they are not in use, extending the battery life. The next I have upgradability. Many firmware systems allow for updates to be applied without needing to replace the hardware. This means manufacturers can fix bugs, improve performance, and add new features through firmware updates, enhancing the longevity and usability of the device. Then next I have security. Firmware can incorporate security measures that protect the device from unauthorized access or malicious attacks. Regular firmware updates can also address security vulnerabilities, ensuring that devices remain secure over time. And next I have cost effectiveness. By providing essential functionality directly in the hardware, firmware can reduce the need for more complex software solutions, leading to cost savings in both development and manufacturing. And next I have easy integration. Firmware is often tailored for specific hardware, allowing seamless integration and communication between the hardware components. This is particularly beneficial in embedded systems where hardware and software must work closely together. Then the last one I have, it's customization. Manufacturers can customize firmware for specific applications or user requirements, providing tailored functionality that meets the needs of different industries or consumer products. Thank you.
Okay, thank you so much, SA2. That was profound. Thank you for your contribution. Let's go to Brandon.
Ms. Linda, I feel like some KLA and SA2 and also Ivana's answer from the previous activity has exhausted the concept of firmware. So can I just move on to the next question, if that's okay?
Yes, you can move on to the next question.
Okay, so software simulation is the use of computer programs to mimic real-world processes, systems, or phenomena. It enables users to test or experiment in a virtual environment without interacting with actual physical systems. Some of the advantages are that it is cost-saving and eliminates the need for physical prototypes, which can be costly and time-consuming. It also allows users to experiment without risking damage to real systems or environments. Simulations can quickly be adjusted to test various scenarios, and also complex systems that are difficult to replicate in the real world can be simulated with ease. Some of the disadvantages are that if the model used in the simulation is flawed or incomplete, results may be inaccurate. Also, simulating complex systems can demand significant computing power and time. And then lastly, simulations often simplify real-world conditions, which may result in outcomes that differ from real-life scenarios. Thank you.
I was on mute. Okay, thank you so much, Brandon, for your answer. Yes, for software, what simulation? Is there anyone who wants to add more advantages and disadvantages of software simulation?
Ma'am Linda, I don't know if Noma Sabata wants to answer, but she said she's struggling with lifting her hand.
Okay, Noma Sabata, you can answer, because I want to know now which question answer. Noma Sabata, you can go.
Okay, ma'am. As software simulation refers to the process of creating a virtual representation of real-world system, process, or environment using computer software. This virtual model mimics the behavior and characteristics of the actual system, allowing users to analyze, test, and predict outcomes without physical prototypes or real-world experimentation. And then advantages: cost savings, reduced prototyping and experimentation costs, increased safety test scenarios without risking physical harm or damage, and then improved accuracy, precise modeling and analysis, and then enhanced understanding, visualize complex systems and relationships, faster development, expedite design, testing, and optimization, and then
flexibility, easily modify and test different scenarios. And then disadvantages, validation, ensuring simulation accuracy and relevance. Data quality relies on accurate input data. Interpretation requires expertise to interpret results. And then maintenance, updating and maintaining simulation software. Verification, ensuring simulation results match real-world outcomes. Over-reliance, relying on solely simulations and neglecting physical testing. Thank you.
Thank you so much, Noma Sabata, for the profound answer. Thank you so much. And thank you, Samkele, for informing me. Okay, thank you, Noma Sabata. That was profound. I think we've exhausted Brandon and Noma Sabat. So we can gladly move to the third of virtual machines. Yes, here I think we are expected to have more answers because everyone gets in touch with what virtual machines, whether you take your kids for games and all, that is also virtual machines and all. You get to see them in your everyday life. Okay. Okay, let's have answers. Let's have answers. Brandon. Yes, who else will come after Brandon? Please, let's learn to participate, class. I gave you time to do the work. We can't just have regular participants. We can't, yes, Brandon, Bubu, Fortunate, Samkele. We can't be having all these regular participants. The people who are the same way have been answering all the questions. Please don't be like that. Don't be like that, okay? So here we are going to have Brandon, Bubu, Fortunate, Samkele, then Tyrene. I think we'd have finished this question. Okay, in that order, Brandon, Bubu, Fortunate, Samkele, then Tyrene.
Okay, a virtual machine is is a software-based emulation of a physical computer that allows multiple operating systems to run on the same hardware, managed by a hypervisor, which can run directly on hardware or an existing OS. VMs share hardware resources such as CPU, memory, and storage while remaining isolated from one another. Some of the characteristics of virtual machines are that each VM runs independently from other VMs and the host machine. Secondly, VMs allow for the shared use of physical hardware resources. Then lastly, different operating systems and applications can be run simultaneously on a single physical machine. Thank you.
Okay, thank you so much for the answer.
Okay. A virtual machine is a software-based emulation of a physical computer. It runs an operating system and applications just like a physical computer, but it does so in a visualized environment. A VM behaves like a separate computer, even though it shares physical hardware resources such as a CPU, memory, and storage with other VMs on the same physical host. So its key components are the host machine, which is the physical hardware that provides the resources to run the virtual machine. It can run multiple VMs. Also the guest machine, the virtual machine itself, which runs its own OS and applications isolated from other VMs. So in summary, the virtual machines provide a powerful way to maximize hardware efficiency, increase flexibility, and create isolated environments for running different OS and applications. They require careful resource management and may come with some performance trade-offs. Thank you.
Okay, thank you so much, Gugu. Then we go to Samkele, then Tyrene.
All right. A virtual machine is a software-based emulation of a physical computer system. Imagine it as a miniature isolated computer running within existing operating system. This virtual machine offers the same functionality as a physical machine, allowing you to install operating system, run programs, and manage files, all within a controlled environment. The benefits are resource isolation. Create an isolated environment preventing conflict between programs or operating system. Flexibility and portability. It can be easily moved between physical machines, making them highly portable. It is cost effective and it is useful for testing and development, providing a safe and controlled environment for software testing. Thank you.
Thank you so much, Samkele.
Ma'am, can I do the next question? Because I feel like they've said everything about virtual machines. So if I can do binding, then is that okay?
Okay, what?
Excuse me, ma'am? Okay, so binding refers to the process of linking a name or reference to its associated value, location, or meaning. Thank you.
Okay, thank you so much. Who would like to add? Thank you, Tyrene, for your answer on binding. Would like to add more on what Tyrene just said? Is there anyone with a different version of binding, Tyrene? Yes, we have got essay to then Google Fortunate. Okay.
Okay, binding refers to the process of associating program elements such as variables, functions, or data types with their corresponding attributes such as memory locations, values, or types at various stages of program execution. This concept is fundamental in programming languages rather, as it determines how and when these associations are made, impacting the behavior and efficiency of software execution. Let me just list the types of bindings without going into details. Number one, I have static binding, which is early binding. Number two, it's dynamic binding, which is late binding. Number three, it's compile time binding. Number four, it's load time binding. Number five, runtime binding. Static binding can lead to more efficient code execution as the compiler can optimize resource allocation and management. Dynamic binding allows for more flexible programming paradigms such as polymorphism, which enables the same function or method to operate on different types of data. Then early binding can help catch type-related errors during compilation, reducing the risk of runtime errors. The response was very long, ma'am, but let me just end it there. Thank you.
Okay, ma'am, can I go?
Yes.
Okay. So, binding in computing refers to the process of associating one entity with another, often at different stages in the execution, such as variables, functions, or resources with specific memory addresses, data types, or behaviors. It happens in multiple contexts, depending on the language or system. So binding is crucial for the interaction between different components of a program, enabling abstraction, resource management, and more efficient use of system resources. Thank you.
Thank you so much. Okay, I was on mute. I was saying thank you, Google Fortunate, for answering, and also thank you, Tyrene and Esset for the additions. Then I was now saying let's move on to the next question. Okay, the next question says, what types of binding occur at language definition and language implementation? I was supposed to say at language definition and language implementation. So what type of binding occur at language definition and language implementation? Okay, I'm not in the enjoyment of calling people's names, and I'll never do that because I don't want to embarrass anyone when they don't have the answers. So let's have participants. What type of binding occurs at language definition and language implementation? Okay, anyone? Okay, thank you, Nosa. Thank you, Noma Sambata. You can go.
Okay, the types of binding that occur at language definition, there are 4 types, which is lexical binding, syntactic binding, semantic binding, and type binding. And then the types of binding that occur at language implementation is variable binding, function binding, method binding, operator binding, and scope binding. Thank you.
Okay, thank you so much, Noma Sabata, for the answer. That was so profound. Let's go to the next question. What type of binding occur at program translation and program execution? What type of binding occur at program translation and program execution? What type of binding occur there? Can you have answers? Can you have answers? Okay, yes, please. If there's no answer, it's fine. You can move forward. I cannot give you the answer. I'm not there to give you answers because I told you to do your work and everything isn't like a learner guide. Okay, Brandon, yes.
Okay, so during program translation, we have compile time binding and static binding. This happens when the program is compiled. The compiler assigns memory addresses or references for variables, functions, and other entities ahead of time. These bindings are fixed and do not change during executions. Examples of variable binding. This is where memory locations for variables are set during compilation. And then I also have function binding. This is when the addresses for functions calls are determined at compile time. Okay. And then program execution is runtime binding. Also boils down to dynamic binding, and this occurs while the program is running. Associations are made based on the actual execution context. Examples include method binding. In object-oriented programming, method calls are resolved at runtime according to the actual object type. And then lastly, I have dynamic memory allocation. Memory is allocated for variables or objects as needed during program execution. Thank you, ma'am.
Thank you so much, Brandon. I cannot give answers. Everything's just there in your learning. Thank you, Brandon. It shows that you really did your work. Thank you so much. Then we go to what is the advantage of bindings performed at translation time and at execution time? What is the advantage of bindings performed at translation time and execution time? Yes, SA2.
Okay, ma'am. For advantages of bindings performed at translation time, number 1, I have performance. Static or compile time bindings allow for faster execution since the addresses and values are already known and fixed, minimizing the overhead of resolving bindings during the runtime. The second one is error detection. Early binding allows the compiler to catch type and scope errors at compile time, leading to more robust code and fewer runtime errors. Then the last one is optimization. The compiler can optimize the code for more effectively rather, because it knows the bindings in advance, allowing for better memory allocation and resource management. Then I have on the advantages of bindings performed at execution time. Number one, it's flexibility. Dynamic binding allows programs to adapt to different conditions at runtime, enabling features such as polymorphism and late method resolution in object-oriented programming. Second one, it's resource management. Programs can dynamically load libraries and modules as needed, reducing memory usage and improving efficiency by only loading necessary components. And the last one, it's support for dynamic data structures. Execution time binding facilitates the use of dynamic data structures like linked lists and trees, where the structure can change during program execution based on user input or other factors. Thank you.
Okay, thank you so much. SA2, we then go to Brandon.
Okay, so my answers have some similarities with the C2s. Sorry. So the advantages of binding at translation time. So I listed 3 of each. So firstly is improved performance. Since addresses and references are determined at compile time, execution is generally faster because there are no additional lookups during runtime. Next, I have predictability. The memory layout and access patterns are known in advance, leading to more consistent and often optimized performance. The third one is early error detection. Many potential errors can be identified during compilation, such as type mismatches or incorrect variable usage. And then the advantages of binding at execution time, hold on, is increased flexibility. Dynamic binding allows for adaptable code. For example, object-oriented programming uses dynamic method binding to support polymorphism, where method behavior depends on the actual object type. Next, I have efficient resource management. Dynamic memory allocation enables better use of memory by allocating resources as needed and freeing them when they are no longer in use. And then lastly, I have adaptability. Programs can adjust to different runtime conditions or configurations, offering more dynamic behavior based on user input or other external factors. Thank you.
Okay, thank you so much, Brandon. Thank you for the answer. Thank you, SA2. And thank you for all the I plan to finish the slide. The formative and summative, so that next week it's okay. Brandon, let me just say
Ms. Linda, your connection is very bad because you are breaking. I don't know if that's just from my side or if it's the
Maybe
same.
it's just me, man.
Okay, can you hear me now?
Yes, we can hear you now, ma'am.
Okay, I'm saying my plan tomorrow is we finish these slides. After finishing these slides, I then give you time to answer the formative and summative on your own. Then Brandon, Tyrene, and Paul, just be ready. It's either between Monday or a Tuesday. You then facilitate the assessments. Why I'm saying either between Monday and Tuesday, I don't know the plan. Remember, I'm still looking for the guest lecturer. I haven't, like you said, to get back to me today. If he doesn't get back to me, either between Monday or Tuesday, you go on with your what? With the assessments. So that is what I wanted to say. Am I breaking up now?
No, ma'am, we heard you loud and clear. Thank you.
Oh, ma'am, I can hear
Okay,
you.
okay. Thank you so much for
Okay,
the
ma'am.
day. Have a pleasant day. Yes, I do. Yes.
I was thinking, how about you just ask him to record himself explaining the concept after hours, ma'am. Then maybe he could send the recording to you, and you could send it to our groups.
Okay, so is it fine with you that if he says he's busy, then he can send record even if it's 1 hour long? It's fine with, are you fine with that?
Yeah, that's a good plan, ma'am.
Okay, so it's fine. I will ask him to do that. I'll ask him to do that. Yes, if he let's hear what he says today, then I think obviously you'll be into that option after hours. He can do that. So let's go to the remaining minutes. Let's go to open your learner guide. Everyone, open your learner guide on LP. Brenton, you seem to be laughing. Open your learner guide and let's go to 14922. No, I just want to hear what you want, yes, to explain, like now that he's doing it after hours, because we don't want him to explain other, because I gave him the whole learner guide and I told him to focus on 14922. So I'm asking now, let's open our learner guide. I'm opening mine. It's all, yes, we'll do it first. Give me what, let's say he agrees to say after hours, what you really want him to get into details of. Let me see. Okay, 14922. Let me just see. I'm not saying we have to learn. I just want to say, like, so that you avoid sticking like to other simple things, like to go into detail with other simple things that are self-explanatory. Let me just say learner guide. It's 6 LP6 here. Okay, I'll open. Well, open yours and tell me. It's taking long to open. Mine is taking long, but I'm opening. So that is what you want to, so that he explains into detail what you want and avoid going to simpler things. I told him it's 14922. Mine is taking long, just to bear with me. Okay, learner guide 6. Let me share with you. Let me find somewhere to write. I want to say stop sharing here. But it's sticking. Is there anyone who can hear me? Okay, let me try to leave and come back. Don't leave the class.
No, ma'am, we can
hear you, ma'am.
No need to leave.
Okay. Let's hope now. Okay, it's refusing to share mine. But let me just also open mine on my side. That's why I was thinking that people are not hearing me. Okay, I think it's stuck. Okay, which one? I'm opening mine, but I cannot share. Okay, which one